This is problem number 9 on the sample test problems for test number 2. The following table gives the percentage of children under 18 in Massachusetts who are not covered by health insurance by year. In the table, years are given as years since 1998. Source, U.S. Census website. Part A, give an equation for the line of best fit for these data, round all values to 2 decimal places. So here I'm asking you to use the technology to find the line of best fit. I'm not asking you to calculate any slopes from these numbers or calculate any y-intercepts. Really just want to know if you can get the calculator to find the best fit line. So here's how we do it on the calculator. First thing we need to do is type the data into the calculator. So we go into Stat. Number 1 is already highlighted. We're going to choose 1 or hit Enter. And we should see these lists. If your lists have stuff in them, you can clear them. For example, if I had randomly those numbers in my list, if I go up to the top and I hit Clear and then Enter, then the list gets cleared. Okay, so we'll type in the data. 0 through 5 are going first. And then in L2, we're going to go ahead and put the y values. So 8.0, 7.9, 6.4, 5.3, 5.9, and finally 7.9. And then we'll quit out of there. And then to find the line of best fit, we have to go back into Stat. And this time we want to scroll over to this Calc menu. And down here in number 4, it says LinReg, which stands for linear regression. So let's hit number 4 and hit Enter. I've got my equation up there. I just have to copy it. So let's go ahead and copy it. It says y equals ax plus b. You know what? Let's just take a screenshot of that so that it's here in the document. Okay, that didn't take. Let's try one more time. Okay, so there's my screenshot, and we just need to be able to interpret it. So we'll go ahead and write the equation. The equation, according to the top here, is y equals ax plus b. A is that first number, negative 0.217. It says round to 2 decimal places. So that's a negative 0.22x plus b. B is 7.44 and change. And that's our equation. And then it says, do you think the line of best fit is a good model for these data? Why or why not? Okay, so looking here, hopefully we know something about the R. The R value in this case is about negative 0.34. If the R value is close to 1 or negative 1, then you have a very good fit. If it's not, then you don't have a good fit. And it feels like negative 0.34 is not very close. So that's one possible answer. So we could say it's close to 0. So it's not a good fit. As a rule of thumb, I don't know, maybe if R is within 0.7, something like if R is something between negative 0.7 and positive 0.7, then that's not a very good fit. Just a rough guideline. That's somewhat unsatisfying. Well, first let's make sure everybody can get that R value. If the R value didn't appear, then what you need to do is go into Catalog, which is down here at the bottom. So we hit second 0. We want to find the phrase diagnostic on. Hit the button right here with the green D on it. And it skips down to the D's. I go to diagnostic on, hit Enter. And then if I do second Enter a couple of times, it'll bring me back to this LinReg. Hit Enter, and it should give the same information, but now if you didn't have the R's before, you should have them. If I do second Enter one more time, and maybe ask it to put this equation into the Y1, then I can look at the picture. So we go to VARs, scroll to the right, hit Enter on the first option, hit Enter on the first option, hit Enter again. It looks the same here, but now it's typed into Y equals. If we do zoom and then scroll up, you can see number 9 is zoom stat. The calculator is very good at finding these dots. course, it only finds them if you turn them on, so let's go back into y equals, up to the top and hit enter on plot 1. And now we'll try zoom stat. And there are the dots, and there's the line, and that is not a good fit. So I went ahead and grabbed a screenshot of that graph. So one possibility was to refer to the R's, or you can say that dots are not close to the line. So this is not a good model.